Our next speaker is Braden Hancock. Braden's a head of technology and the co-founder for Snorkel AI, which, of course, y'all know is one of our sponsors at Southern Data Science Conference. He has previous roles from Google, Facebook, and Stanford. He also got his PhD in computer science from Stanford University. And when I asked Braden, what would you consider to be kind of the phrase that pays for you? He said, really, it's about being a researcher and able to solve problems in creative ways. So welcome, Braden Hancock.
Mic. Test, test, test. There we go. Great. Thank you so much for the introduction. And it's great to be here. It's an honor to speak at this event and to be one of the sponsors and to connect with the Atlanta community. Thrilled to be here. It's nice to be able to say that I'm coming to Atlanta to cool down given the current heat wave in San Francisco. I did not expect that, but an unexpected surprise. So as was mentioned, I'm one of the co-founders of Snorkel AI, and talking today about building AI applications quickly, very quickly, in a day sometimes even, with data-centric AI. So let's start by level setting on what I mean by data-centric AI. I'll start with what I imagine is a fairly uncontroversial statement in 2022, which is that data is, of course, absolutely crucial and key to success with AI, right? To build high-quality, domain-specific AI applications, you need high-quality training data, and often quite a bit of it today, given that we have these powerful but very data-hungry model classes that we're working with. And the good news is that most enterprises, likely yours included, have plenty of data, massive amounts of data, and that's embedded in contracts, documents, chat logs, health records, all sorts of different types of formats. And that has the potential to be an incredible competitive advantage. There's so much you can do with data, and we've seen that, I think, over the past decade pretty thoroughly as people find ways to drive customer satisfaction up or increase revenue or do different things. The bad news, of course, is that most of that data is unstructured, unlabeled, and not actually ready to be applied and converted into AI applications. And that data can't be used to train models until that's been done. But the predominant way of labeling data, which is done via manual process most of the time, it can take weeks or months to do, becomes this inevitable bottleneck in just about every AI application that you want to take to market. And it gets worse because this labeling cost is rarely just a one-time cost that you pay up front and you're set forever. There's always, it's a development process. There's always iteration involved. So at the beginning of a project, you'll see subject matter experts and data scientists work together to define the problem, figure out the labeling schema, calibrate the annotators, figure out how you're going to deal with different edge cases. And then even after you've done that, there's always emergent needs that arise, whether that's the data has shifted over time or we need to change a little bit what our output schema is. And so there are needs to go back to that labeling process over and over and over. And it adds up. This heavy manual process that was already a bottleneck becomes even worse if you're trying to do AI in an intelligent way, which requires iteration. So this means, obviously, that the data has become a bottleneck. It is throttling the progress of many AI applications, but it's also an opportunity, and increasingly it's the interface through which AI practitioners interact with their AI systems. You spend a lot more time today in this data-centric world focusing on refining, improving, and understanding data quality rather than assuming a fixed frozen data set and then beginning to hyperparameter tune and boiling an ocean looking for the best local optimal weights. Assuming that you can't do anything about what's actually teaching your model what it needs to know. So this new reality of a data-centric world requires new workflows, new tools, and this is what's really motivated the Snorkel team from the very beginning of the project. We originally began as part of the Stanford AI Lab, a bunch of wet behind-the-ears PhD researchers, looking at kind of the way the winds were blowing, seeing that models were getting increasingly available, accessible, high power, and frankly, standardized, commoditized. Fantastic modeling libraries mean that you can, with a few lines of code, be training the latest, greatest transformer or ResNet or whatever the flavor of the day is. That's rarely your bottleneck or your differentiator. Almost always it's the data where you end up needing to have higher leverage ways of operating if you want to increase the speed with which you're able to build high-quality AI applications. So this is where we focused for many years as researchers, and then the past 3 years as a company, building a platform based on all the things that we learned from working with fantastic agencies and enterprises in this space. So to ground this in a concrete example, one of our very first customers was a large US bank, and there was a regulatory change that meant that they suddenly, urgently needed to identify where they were exposed to certain risks in their loan portfolio. And they knew that this wasn't going to be an easy process because they had recently completed a similar process based on another regulatory change, and this is what that looked like for them. It was about 6 person months of labeling. It was a fairly nuanced task. This is legalese, which you need to be fluent in to understand which contracts do and don't apply. So they needed to use experts. And the actual modeling part was fast. That was about 1 day. They actually told us they used 50 lines of code from a Coursera course, and that gave them a pretty good model without too much trouble. But then once they had that model trained, they ran it by their downstream business users and found that, oh, actually, those 8 classes you gave us, that's fine. We need a little finer granularity. Could you update your labels to work with our 30 classes that we'd rather have? And this, of course, meant going back and relabeling, retouching every one of their data points. So exactly the kind of cycle I showed you before, where inevitably, it's an iterative process that's required. So this was, needless to say, extremely painful. And double-clicking on what their labeling options were, to that point, they'd considered basically 2 options. One was do it in-house, 2 was outsource it. And on the outsourcing side, that got shut down pretty quickly just from a privacy perspective. So many different types of data, whether that's financial data or legal data or medical data or intelligence data or you name it. There's all sorts of reasons why you can't stick your data up on the internet for random strangers to label for you. If you're labeling cats and dogs, sure, or even stop signs, things that are very simple that require no specialized knowledge, that's not a big deal. But for them, they had both privacy requirements, as many folks do, and they just knew that they would get too low quality of labels if they had anyone other than their in-house experts working on it. So they had to opt for the in-house labeling, and they tried to speed up their annotators, make them a little more efficient by doing intelligent selected orders, active learning, or giving them kind of nudges in the right direction with like model-assisted labeling and smooth keyboard shortcuts. But still, the fundamental bottleneck remained that each and every label that they wanted to collect required human time looking at each and every document. And so there's just no way for them to really get out of, in a significant way, that big, heavy, upfront labeling process that they had. So I'll tease a little bit, and then don't worry, I'll show you more in a moment on the details of how they did this. But we worked with them to convert their manual labeling process to a programmatic one with Snorkel. And at the end of this, they were able to label all of their documents relevant to this corpus, so about 250,000 documents. They were actually able to go through multiple different, increasingly relevant versions of their training labels on those documents in a day. And when they did inevitably need to make changes to the model, that became something that they could do in minutes or hours rather than, again, sort of weeks or months. So a much more favorable sort of end state to be in. And the key is basically changing the interface at which you interact with your ML systems, and specifically your labeling process. And I'll show you what I mean. So this transition from heavy upfront manual label collection to something more agile, more iterative and programmatic, this is all part of what we consider the data-centric workflow, which I'll now go into detail on. So the important kind of first bit to understand here is we're changing, as I mentioned, the interface, basically the inputs that we collect from users. So if you're going and, actually I'll move to an example here. Move forward, there we go. Suppose I'm creating a spam classifier, a very simple task we all, I think, understand. One way I could do this is to pull up 100,000 individual emails, read each one, figure out why I think this is spam or not spam, and then throw away that reason and just give a label to my model. And after I've done this, 10,000, 20,000, 100,000 times, I've got a labeled data set to teach my model, basically assuming that it's going to try and relearn some of the reasons that I already know, but kind of throttled through individual labels. Instead, what if I could tell it a little more directly my domain knowledge? What if I could say, the reason that I labeled this example and hundreds other like it, in my data set as spam is because it had certain features that I, as a domain expert, know tend to correlate with, with the spam label. So, dear sir or madam, I have a great opportunity. I just need you to wire transfer this. Do it now, save money. There's all sorts of shifty things you could see in the content of the email or in the metadata, maybe coming from a shifty IP address or different things. Lots of reasons that I could give that could be encoded in a function and applied to hundreds or thousands of data points, applying my domain knowledge, but without me needing to touch each and every individual example. And that's a very important idea that allows this type of scaling difference that I've sort of teased. And then to look at what you do downstream with these labeling functions that you come up with, various rules or heuristics that you could think of to apply, they're not going to be perfect. They're not going to have all the nuanced understanding of the domain that you do. And so there are going to be places where they don't apply. Examples where that function has nothing to say and so will abstain. There'll be situations where these functions overlap with one another, conflict, or agree or disagree or correlate. Lots of sort of noisy sources of input. But you can think of sort of like the wisdom of crowds, like the classic ask the audience in Who Wants to Be a Millionaire, that always kind of was amazingly accurate by the time that you aggregate a number of different sources, even if none of them individually are perfect. And that's essentially what we do here. So we spent some of our time in the years researching this at Stanford identifying the provably sort of optimal ways under different assumptions of combining a bunch of weak sources of supervision to create high-quality training labels, but importantly, now created in mass, in minutes or seconds, by functions that work at computer speed rather than by individual humans working at human speed to create these labels. And once you've got that training set, you can train a model which generalizes beyond what you showed in your labels. So you can imagine a classifier trained on the data here in this center figure would end up being able to do a pretty reasonable prediction job on most data points, even those that weren't covered by one of our labeling functions. So a bit in the weeds here, but I think it's important to understand that with this process, with this workflow, you end up getting kind of the best of both worlds, and that your output is still a state-of-the-art machine learning model with all the benefits that brings, a robustness and better way to handle, I'd say, edge cases and things than a relatively brittle rule-based system. And yet your inputs are these things that look a little more like rules, which are much more interpretable, easier to update, adapt, apply at scale, and work with in a whole bunch of different ways. So to emphasize, it's not even just really about speed, it's really about iteration, right? As we mentioned, training data development should be seen as a development process, something where you can take a look at your model's performance today and improve it via your data set. And so what you end up getting with this type of a transition to this data-centric workflow is the ability to efficiently update the behavior of your model very quickly. I think of it as basically giving you access to much larger levers as you sculpt your data set rather than kind of one by one sorting skittles or individual data points. That's always the image that comes to mind for me. But you end up, the proof's sort of in the pudding when you look at how long it actually takes to get high quality models trying these different approaches. So this is an exciting idea, of course, that you can create larger training sets more quickly, but there's an even bigger idea here. What we're really trying to enable with this change in paradigm is the ability to operationalize organizational knowledge. There are lots of different things that most enterprises have with knowledge in them. That could be domain experts with knowledge in their head. That could be resources, and I'll go into detail on what some of these could be. And it includes some of the great recent work you'll see in foundation models, which likely if you've been on ML Twitter, I guess you've been seeing some of these exciting demos in recent weeks or really months. But to dive into these a little more detail, one thing that you can use in this paradigm is manual labels. If you've got them, you don't need to throw them away. They're reusable. Wrap them up and toss them into this melting pot where you're going to combine a lot of different types of signals. So labels work great for this, and that can include relatively noisy labels. You can use less than experts or external vendors, or you can use your experts, but by modeling a little more intentionally, by tracking which labeler provided each label, you can actually come to automatically learn which ones are more trustworthy than others, or which ones have certain areas of expertise where their vote should be more trusted than in others. And so this looks a little more like your traditional labeling setup, but with some sort of freebie points, by just being a little smarter about what you track. But you can combine that with other resources then. So often there are annotator instructions or ontologies or knowledge bases or blacklists or different things that you already have where knowledge about your problem is in fact already available and encoded, just hasn't been in the past easy to apply to your problem. And this labeling function abstraction gives you an easy way to wrap up a knowledge resource and have it convert into noisy labels on some portion of your data set, which can now be easily combined, scaled up, and worked with. And then in this third bucket are some of the nice advanced techniques. Includes some number of years of research that we've done on how to automatically suggest labeling functions inferred from your data, but also an area that's particularly exciting right now in the ML community which is working with these really, really rich models, sometimes called large language models or foundation models. And I'll show it with the next few slides how that might look. Kind of conclude things here. So as a recap, what's a foundation model? You've probably heard of some of these: DALL-E, GPT-3, BERT, Stable Diffusion's one in the past month. These are massive models trained actually using fairly well-known techniques like self-supervision, but trained often on substantial portions of the internet and with billions or even approaching trillions of parameters. So they're able to learn a whole lot in this process. But they're not necessarily learning all about your problem. They're learning in general about the world, about the internet. In the process, they learn a lot of useful skills that could transfer to your problem, but you can think of them as I mentioned, generalists. So that means they may know something about spam classification or financial document parsing, but they also know something about pickles and bratwursts and mowing lawns. Like they pick up all sorts of knowledge here. So on the plus side, they're very powerful. They're a great base upon which to build and add kind of domain-specific knowledge that you have to map what they know to your problem. But they're also rather inefficient in that these trillion parameters, you probably only need 1,000th of that or 10,000th of that to actually do a good job on your problem. Because you don't need, most of the time, you don't need general AI. You need something relatively specific and focused. So what we want to do is pull out the relevant parts of what these models know as a relevant organizational resource without having to pay the cost of lugging around and supporting this massive model that requires specialized hardware and everything else. And so once again, Snorkel and programmatic labeling provides a nice framework for doing this, and that this is basically now one more resource that can be tapped into and provided in your pipeline. And the way that you can do this is by basically once again using your domain knowledge to kind of identify the relevant things it might know about your problem. So for example, on the spam classification task, you could ask it, is this email spam or not? And it may, with some accuracy, get some examples right. But you can also take other things you know about spam classification, ask the model, is this email trying to sell me something? Is it talking about money transfers? Is it mentioning prescription drugs? And on each of these types of questions, it'll also have, with some accuracy, some ability to propose labels. And this becomes, yet another source of signal that can be laid on top of the other things you're creating. So you get all the knowledge that you need conveyed into your training set for your model to be created and be high quality, but still preserving this really desirable property of having a programmatic labeling process where the human doesn't need to touch each and every individual data point. So stepping back, at the end of the day, what is it that you're enabling with this? It's the ability to use all available resources that you have. It's the ability to transfer knowledge more efficiently from your organization, from your experts, into a model, removing this bottleneck, keeping the lingua franca of training labels as a way to transfer information, but creating these training sets in a much more efficient way. And that now lets you adapt far more quickly, scale far more large scale, I guess, in scope, and most importantly, stay very close to your data, really controlling the primary asset that's going to be the differentiator in whether you're successful or not in your AI endeavors. So I'll pause there and take some questions. This is stated at a fairly high level today in the realm of slides, but we'd love to give a demo to folks who are interested if you go on our website and have specific use cases you want to see about. And then, of course, we're on social as well. So with that, I'll pause and take some questions.
Thank you, Braden. Fantastic. What questions do we have? Yeah, I'll get this one.
Yes, or I'll let you drive.
Yeah, thanks for the talk. And this is a very important problem that almost all company faces. So I'm curious, what are the measures that you're doing to understand that the labels are accurate? Do you do it before the model is built itself, or do you do it based on validating the model on a new set to know how good was the label quality through these functions?
Yeah, no, the evaluation question is one that's very important to get right. And that's one place where I'd say, don't mess with the standard approach of, you want to score in some held out test set, right, at the end of the day. And so typically what you'll do is if you have any labeling budget at all, you save, your ground truth labels for evaluation, for confirming at the end of the day that what you're doing with your training set is resulting in improvement in quality. But then your training set can be something where you can iterate much more quickly and not necessarily have to have ground truth labels for those. So if that answers, basically evaluation you keep separate on your highest quality labels. Training labels, it doesn't that doesn't actually matter, I guess, if any individual label is correct, so long as at the end of the day, your model is being taught the things that it needs to, via that training set that you're creating. And I guess I'll add just there, if you ever do discover bias or systematic errors that you want to correct, you now have the nice property of you tweak a line of code, you push the re-execute button, and regenerate the entire training set without that source of bias, rather than if you had manual labels in your training set, which you would then need to go and manually modify. Here we go.
All right, we got one in front. Yep.
How does your process slot in with existing bootstrapping methodologies like regexes and all of those different heuristics that are just kind of an inherent part of the process?
Yeah, so the framework's quite flexible in that a labeling function is an arbitrary function that takes in a data point and outputs a label that in general is better than random chance, right? So that can wrap a lot of things, as we mentioned here. That can be models, that can be labels, that can be other resources, that could be a regular expression. And that's in some ways kind of the simplest class you could think of highlight the word that told you why you should label this a certain way. And that plugs in just fine. But now with the added benefit of you not having to kind of construct yourself when you should trust which regex over another, like manual tie-breaking, basically constructing that decision tree. Now you can just toss it in and then let sort of the statistics infer the optimal way of combining these to create the highest quality ultimate label after factoring in all these different types of signal. A couple over here. Yep.
Okay, I think part of the question I had was the first question that you already answered, but how would you measure you said you evaluate the performance of the labeling system based off of the test that you have, but how would you deal with the change in the data? And the other question that I had is, so you discussed about the knowledge functions. So are those knowledge functions specific for each business and each use case? And if so there is no information shared across those knowledge functions, right? Or you actually do that? Like how those knowledge functions work within your systems?
Sure. So every application that you tackle, you've got some decision boundary basically that you want your model to learn. And you can warm start your problem using various things like a pre-trained model or like a pre-existing data set, but they're almost never like a perfect fit out of the box for exactly the decision boundary that you have in your head. So there's always a conversion process that's required, that sort of last mile adaptation. And there's different ways to do that. The most frequent is to create an extra relevant training set to your problem that you then fine tune a model on. So these labeling functions that you're creating are for creating that kind of finest grained conversion last step. And the functions that you create, often like you'll assign to each application that you're making the functions to make the training set for that application. But often these are reusable. If you're working in spam detection and you want to classify a number of different types of spam, whether that's phishing schemes or I don't know, I'm not very good at spam, but a lot of different types that you could think of. It's easy to imagine that actually labeling functions that were written for identifying spam on Twitter or spam in emails or spam in chats apply across domains. Similar types of keywords, similar types of structures, similar types of red flags. And so we actually do find that organizations like that bank I mentioned, they now pump out a new classifier a week as they have different applications they want to spin up. And they often are reusing those resources, picking and choosing which ones are relevant to the new problem, and then adding the small handful additional ones to kind of complete the mapping to the new problem they care about.
Excellent. Thank you, Braden.
Fantastic. Thank you.